All right, so you're working on Unit 1, Appendix 2, Scientific Notation. What you're about to see is a 3-minute clip from a longer video that I have made. So, though the question numbers may be different, you see some other text around, focus on what's being covered within this video and it'll cover what you see in front of you. Without further ado,
here are magnitudes listed. On question 15, magnitude. So this magnitude is 0.000001. 2, 0000000. You see what we got written over here. If you were to put this in scientific notation, you're used to making the loops. The decimal, if we put this really in standard scientific notation. Standard scientific, we want the decimal, currently is right here. We want it over here. Immediately to the right of the first non-zero. How do we get there? Well, let's just count. 1, 2, 3, 4, 5, 6. It's a 1 times 10. There has to be a 6 up there. Is it a positive or a negative 6? Well, again, go back to that basic rule. Don't get fancy about, oh, I moved to the right and moved to the left. Is it a big or a small number? 0.000001, that's a small number. It gets a negative. There it is. 1 times 10 to the negative 6, aka 1 millionth. Done. Let's go over to the next one. If you don't see a decimal written, just pretend there's a decimal, a little phantom decimal here at the end of the number, all the way to the right. We want it immediately to the right of the first non-zero. So the very first non-zero is at 2, and we got to move over. 1, 2, 3, 4, 5, 6. Okay, this is now 2 times 10 to the, is it positive or negative 6? We move 6 places. That's 2 million. That's a big number. It's a positive 6. Done. Next one. All right, we want to move our decimal here. Immediately to the right of the first non-zero, that moves 1, 2, 3 spots. So we have 4.321 times 10 to the, we move 3 spots. This was a small number. We're going to put a negative there. 750. Okay, immediately to the right, boom, boom, 1, 2. So 7.50 times 10 to the, move 2 spots, it's a big number, positive 2. And then finally, 1, 2, 3, 4, 5. We want that decimal right there. And we have 4.0 times 10 to the, we move 5 spots, it's a small number, make it a negative. Now before we continue, there's some Sig Fig business going on up here. You want to maintain your Sig Figs. The original number, the original magnitude is what gives you the Sig Figs. So let's check out, what did we do over here? Is this fair? These were all lead zeros, so no, 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 no. None of those were significant. This was one Sig Fig, so we're good down here. Trail zeros, if you remember, were our exception. That was that funny scenario we weren't sure. This one could be any number of Sig Figs, ranging from 1 up to basically 6. If it were 7, we'd put decimal at the end. So you can have anything in there. This one is really a little tough on the Sig Figs. You need more information. This one, lead zeros are out. 1, 2, 3, 4. 4 Sig Figs. 1, 2, 3, 4. We're good. This one, lead zeros are out. All these, there's a decimal there clearly. 1, 2, 3 Sig Figs. 1, 2, 3 Sig Figs. We're good. Here we have lead zeros. They're all out. And then 1, 2 Sig Figs. 1, 2 Sig Figs. We're good. Okay. No test anxiety on that. But you can do it, so you might as well. It's the right way to do it. Now
we're jumping ahead in the video down to what's listed as question 16 here, but you have the same magnitudes, actually numbers on your paper, although it's not called question 16. So we're going to do the reverse. Take our scientific, turn it into standard.
Turn these into standard notation. So now we're trying to get rid of the scientific. Okay. We're going to skip number 1. We're going to come back to that one. The others are actually a little easier. Let's go to number 2. This is 2.5. We'll rewrite it over here. 2.5. The instruction is to move the decimal 4 places. If you go back to the note at the top of the page, you don't need, oh, go to the left, go to the right. Get that out of your mind. Big and small. You won't forget it. 10 to the 4th, that's a positive. Make it bigger. Move it how many spots bigger? 1, 2, 3, 4. The new decimal will be here. That's out. You actually don't need a decimal over there, but 1, 2, 3, fill the loops. And the answer is 25,000. If you look originally, this number is 2 Sig Figs, so your answer should be 2 Sig Figs. You don't need a decimal on the end of it. Next one, 0.5 times 10 to the 1. That's an instruction to move the decimal one place. It's a positive, make it one bigger. Now it becomes, plain old, 5. Still one sig fig. 8.25 times 10 to the minus 6. 8.25. The instruction says move it 6 spots. Which way? Forget left and right. It's negative. That means it should be smaller. So go to the smaller side. 1, 2, 3, 4, 5, 6. You will need a decimal here. 1, 2, 3, 4, 5. Fill the hole. Put a lead 0 out there. Your answer is 0.123, 1, 2, 3, 2, 5. There it is. Written out nice, neat. Finally, 1.11 times 10 to the third. The instruction is to move it 3 spots. Positive 3 means bigger. 1, 2, 3. Fill in a 0. Your answer is 1,110. Actually, if I'm going to be true to the spacing, 1,110. There it goes. Notice we had 1, 2, 3 sig figs, so 1, 2, 3 sig figs is good down here as well. Change that color. It looks like exclamation points. Now, the one we didn't do is this one. 10 to the minus 1. Some of you are going to say the answer is 1. But you see, you'd be mistaken. If there is no coefficient, in front of your 10 to the, put a 1 in front of it. This is identical to 1 point times 10 to the minus 1. And now, do the same exact thing. All right, take the 1 point. We take the 1 point and move it 1 spot. 1 point, 1 spot, bigger or smaller? Smaller. Boom, there it is. Answer, 0.1. So put the 1 point in front of it in case you're not sure. This is 0.1. 10 to the minus 1 is 0.1. It's not 1. Finally, just a sig fig review. How many sig figs from question 15 and 16? Well, 16 is right in front of us. Let's do it. This one here, that's just 1. You see, you look back at the original. That had 2 sig figs, which we were saying before. Choice 3 had 1 sig fig. Part 4 had 3 sig figs. And part 5 had 3 sig figs. The original notation will give you the right answer. Back on question 15, let's count those up again. Where is it? Here it is. We go from the original. We counted them before, but it was 1. Anywhere from 1 to technically 7, but more likely 6, 4, 3, and 2, which we did count up before. That was 1, anywhere from 1 to technically 7, but more likely 1 to 6. Again, don't worry much about this one. And then what did we have? Was it 4, 3, and 2? That's nice and easy. All right, there we go. More fun than you could shake a stick at. Hopefully you learn a little something.
All right, so here's the final piece of scientific notation. Just doing some math with it, doing some algebra, doing some PEMDAS. So here are the tips up here that you might have to deal with. Multiplication, division, raised to a power. Addition, not as common, but sometimes it shows up. So generally pretty easy to do in your head, and there's a reason for that we'll see down here. So there are 4 questions down below, same on left and right. Approximate the power of the answer to each. That's called ITR. Is this reasonable? And then we'll calculate each. So yes, I know that you can put these in the calculator and get an answer. That's fine. We'll look at that very briefly at the end. What I'm more concerned about is, can you do this in your head? Because sometimes you need to. And can you tell when your calculator's provided you a reasonable response? So we're going to look over here. Now, roughly speaking, if you needed to approximate the power of the answer, 10 to some power is what we're looking for. Well, you just look at the power of each piece that goes into the problem. So this is 3.5 times 10 to the 4th. This is 2 times 10 to the negative 5th. Roughly speaking, you can think of this as 10 to the 4th and 10 to the minus 5th. They're being multiplied. So multiplication, you add the powers. You should know that. And in case you forgot, here it is. So you would say 10 to the 4th times 10 to the negative 5th. And again, you can do this in your head. But this is just equal to 10 to the 4 plus negative 5. and that, of course, is 10 to the negative 1. So the power of our answer should roughly be 10 to the negative 1. Of course, the fact that we have coefficients is going to change that, but that's our approximation. Let's keep going on our approximations. This one is 4.5 times 10 to the 4th divided by 2.0 times 10 to the negative 5th. So this is a division. Again, we can approximate these as 10 to the 4th, 10 to the negative 5th. If we're going to divide these two, so 10 to the 4th divided by 10 to the negative 5th, the rule, which you should know, but if not, here it is. When you divide, well, you then subtract the exponents. So this actually becomes 10 to the 4 minus negative 5th. And of course, subtract the negative is plus a positive. So that is just 10 to the 9th. So we would expect our answer to come out to roughly 10 to the 9th. Now, this is a particularly useful skill when doing division. If you pump this into your calculator like this, and we saw this on the EE button video, but if you pump it in like this, you're not going to get 10 to the 9th. It'll actually give you something like 10 to the negative 1st. All right, let's keep going. This one. All right, we have our 10 to the negative 4th, and now we're actually raising to a power. Well, what do you do with the power? Here it is. 10 to a power is multiplication of the exponents. So this is approximately 10 to the negative 4th, whole thing, that's a negative 4th, whole thing squared, or raised to the 2nd, which is just 10 to the negative 4 times 2, which then gives you 10 to the negative 8. All right, there's your approximation. Now, we'll see why those are useful again in a moment. Final one is subtraction. We got 10 to the 12th, and we have 10 to the 13th. If we had 10 to the 12th and 10 to the 12th, this would be very easy. For example, down here, let me change the numbers. Let's say we had a 7 times 10 to the 12th minus 4 times 10 to the 12th. Well, that's basic business right there. That one is just 7 times 10 to the 12 minus 4 times 10 to the 12. 7 times minus 4 is just going to be 3 times 10 to the 12th. 10 to the 12th is what we expect. In addition or subtraction, the power, I guess if we'll do the is this reasonable version first, the power is going to roughly stay the same. And truthfully, roughly speaking, the bigger power should win. So 10 to the 13th is a bigger power here. So we're going to roughly say that this answer is going to be 10 to the 13th. These two are the same, so it should be 10 to the 12th. Okay, fine. Here, the rule, type it in. Generally, so roughly, put an approximately bigger power wins. You're doing addition and subtraction. And that comment is also at the top of the page in the notes up here. There it is. So if these two are the same, well, there it is. Add up the coefficients. Here, if they're different, make the powers the same, you need a common power. And generally speaking, the big power wins. All right, so let's go actually look at these over here. Let's get the equalities. What do they come out to? Well, if you actually do this math, put it in a calculator, boom, boom, boom. You can do this in your head, by the way, too. It's just, in case you were unsure, let's switch over to green. It's just coefficient times coefficient and power times power. So this 3.5 times 2 is actually 7 times, and if you put this in your calculator, you're going to get 10 to the minus 1. Okay, so here's the deal. Why did we compare? Well, is this reasonable? Question here. Is this reasonably close to this? Basically, if you're within 1 to 2 powers of 10, you're probably close enough. That 7, of course, comes from those coefficients over here. So you're probably close enough. All right, that tells us, really, the main purpose of it, tells us that we didn't make a mistake with our calculator. Because when you're punching in a calculator, it's hard to know when you're dealing with funny powers whether the answer is right. You just trust the calculator. Well, sometimes you hit a key. All right, next one. This is 4.5 times 10. This is division. Well, you can kind of play the same game. Coefficients divide, powers divide. So 4.5 divided by 2 is actually 2.25. And then if you put this in your calculator, it will say 2.25 times 10 to the 9th. Actually, it'll probably say E9. That just means times 10 to the 9th. That's what you should write. So first question is, are these reasonably close? 10 to the 9th, 2.25 times 10 to the 9th. I would say so, yes. The second question, by the way, again, you're not penalized for it in this course, but you should know Sig Figs. This was 2 Sig Figs. This was 2 Sig Figs. Answer, 2 Sig Figs. Multiplied. There's the fewest number of Sig Figs. Perfect. This was 2. This was 2. This is actually 3. So we actually need 2. So we can call this 2.3 times 10 to the 9th. So doing this to Sig Figs, that's really the right answer. All right, next one. 2.5 times 10 to the minus 4th squared. Well, the squared actually applies to both of these. So you can do it in your head that way. 2.5 squared, that's like 25 squared, but you need a couple decimal places back in. Put it in your calculator, you'll get 6.25 times 10 to the negative 8. Okay, now over here, we approximated that this would be 10 to the negative 8. And in fact, this seems reasonable. By the way, it won't always match. I mean, all of ours are kind of conveniently matching. I guess I picked easy examples. They don't have to match. I mean, just imagine if this were instead 6 times 10 to the 4th up here. Heck, I could even write it in for you. If this were like 6 times 10 to the 4th, and then times 2 times 10 to the negative 5th, maybe I'll stick this one on the bottom in the actual printout notes. Well, then what you'll get over here, 6 times 2 is actually going to give you 12 times 10 to the negative 1. And when you make this into standard scientific, that's actually going to be 1.2 times 10 to the 0. That's something we talked about on the previous page, which of course is the same thing as just 1.2. So you'll see that power, you would have approximated the same minus 1, but you would have gotten 0. But that 2 would have been close enough. All right, there's a little rounding rule that we'll learn about later that could help you know when to call this 10 to the 4th versus 10 to the 5th. All right, back to this one over here, Sig Figs, 2 Sig Figs. The power of 10 doesn't carry Sig Figs, so the 2 Sig Figs right here. So this actually should be 6.3 times 10 to the minus 8. All right, and let's look at these last ones down here. So this is 7 minus 4. Now, if you put this in your calculator will make the adjustment for you. You're going to end up getting, well, I could do it for us right here. You want these two in the same base, the same power over here. Same base 10 and same power. So you have a 12 and a 13. Pick the one you want. It doesn't matter. You can make them both 12. You can make them both 13. Heck, you can make them both 10 if you feel like being cute about it. But so I could rewrite this as 7. Let's say we want to make them both 12 times 10 to the 12th minus, now if we make this times 10 to the 12th, you made this 1 power of 10 smaller. Well, this then needs to get 1 power of 10 bigger. This would then be 40 times 10 to the 12th. It's the same thing as 4 times 10 to the 13th. You can put those in your calculator and press enter to see that they're the same. So here, really, now we can do 7 minus 40, which is going to give you negative 33 times 10 to the 12th. And of course, if you rearrange your decimal position to make the standard scientific, this will become negative 3.3. So we made the 33 1 power of 10 smaller. So you got to make this 1 power of 10 bigger, 10 to the 13th. There's your answer. And we approximated 10 to the 13th. Boom, that's what we got. All right? If you had instead set this one up as 10 to the 13th, you would have had minus 4.0 times 10 to the 13th. And this one, to make this 10 to the 13th, Well, you're now making it 1 power 10 bigger, which means you got to make this 1 power 10 smaller. 0.70, keep those two sig figs, and that would come out to, of course, exactly -4 and 0.7 comes out to -3.3. Same thing again. There it goes. Okay? And of course, this one down here, I don't think we really need to see. It's already in the same, so this just comes out to 3 times 10 to the 12. They already have the same 10 to the 12. By the way, Sig Figs, the rules for addition and subtraction, it's the fewest number of places after the decimal. So no matter which way you look at it, let's see. I mean, you got 1 after the decimal in each case. I know you get the power of 10 moves it around a little bit, but your 3.3 should be okay over here. You know, if you do it with this subtraction. For your 13ths, you have 1 after, you have 2 after, well, you take the 1 after. All right. So that's basically what you should come in here knowing how to do with scientific notation.